Pythagorean theorem or something, but we don't have all of our sides and we only have two of the angles. So we're going to have to use something called the law of sines. So that is A is equal to B times sine of alpha divided by sine of beta. So B is going to be this length down here, the hypotenuse, right?
Okay.
And we need to find A, which is AB, correct? So we're given two angles, but neither of them is alpha. So as you guys know, all of the angles in a triangle must add up to 180. So we're going to subtract those other two angles, the sum of those two angles from 180 in order to find what alpha is. So alpha should be 25 degrees. After that, just plug and chug. So A, which is equal to AB, is going to be 10 centimeters times sine of alpha, which is this 25 degrees that we just found, divided by sine of beta. Now, beta is the angle opposite the hypotenuse. So it's going to be sine of 110 degrees. So the length of AB should be equal to 4.497 centimeters. Everyone clear?
Yep.
Yeah.
It's one formula. Plug and chug.
Plug and chug, baby.
I remember when questions were this straightforward.
Those were the good old days.
That was the good old days. All right. So I'm gonna go ahead and have the participant thing open. If y'all ready to move on, give me a yes. If not, then no.
Yes.
Yes.
Alrighty,
All right.
moving on. So I think I'm doing number 2 as well.
Yes.
So it's this, right? So we got 1 minus I squared over 1 plus I squared. You guys remember that the square root of -1 is equal to I. So we're supposed to simplify this. All right, so let's start by writing this out. So we're going to have 1 minus I times itself divided by 1 plus I times itself. You guys remember good old FOIL method, right?
Absolutely.
So you multiply the outer number of your first term with both the inner and outer number of your second term and vice versa. Does that make sense the way I explained it? You guys all know FOIL, right?
I think we know. Yeah. I think we.
Yeah. No, it's good.
Yeah. So distribute that. Get 1 minus I plus I squared. And on the bottom, we're going to do the same thing. So we're going to get 1 plus I plus I squared. So let's combine like terms. 1 minus 2I plus, remember this is square root of -1 squared divided by 1 plus 2I plus square root of -1 squared. This is 1 minus 2i minus 1 over 1 plus 2i minus 1. And just a little note, normally when you multiply two negatives, it should be a positive, but in this case, multiplying -1, square root of -1 times the square root of -1, correct? So this is essentially equal to -1 to the power of 1/2 times -1 to the power of 1/2. You guys know when you multiplying terms with exponents, you just add the exponents, right? So this is -1 to the power of 1/2 plus 1/2, which is just equal to -1. So then 1 minus 1 cancels, and I think we should get minus 2i over positive 2i. Which of course simplifies to -1. Right, pretty straightforward, just weird random math.
Yeah, got it. Got it.
Everyone good?
Yep.
They give us
Yep.
I is equal to the square root of -1 too, which is a good thing.
What was that?
They give us that I is equal to the square root of -1 in the question.
Yeah, they stated that.
Thank God we don't have to memorize that. 'Cause
Dude, we're electrical engineering students. We should know what I is.
oh no, bro.
Oh, I lose J.
Oh,
I know.
that's true. That's true. We use J.
Yeah.
Eyes in here.
But I only know because Tabrizi says like 1,000 times that we use J, but it's really I. It's the same thing.
She explains it 10 times.
Zillion times. I did zillion examples.
Cool. Thank you.
Alrighty. I'm gonna stop sharing for now, and let's move on to the next one.
And also, if you would please.
Wait, that's me?
Number 3? No?
Oh crap. I guess
That's
I
fine.
didn't
If you-
look at 3.
if you did it, you didn't-
Let's skip 3 because I don't know what linear is or discrete algebra or any of that.
No
I didn't take
problemo.
any. Did anybody take linear or discrete mathematics?
Nope.
No problemo.
Yeah.
I second
so-
Sebastian's motion to move.
What?
What? All right.
I didn't hear what he said. Okay, well, I guess I'll share anyways. I'll do number 4.
Oh, you sure? Justin was going to do number 4.
Oh, Justin, you do number 4?
Yeah, I can do it. Yeah.
Okay, go for it, bro. Handles.
Justin, you want me to put the thing up on the? You want me to screen share? The question on here? Or how do
If
you?
you guys need the question, sure. I was just gonna write it out in paper.
Oh, go for it. Whatever you want to do, my guy.
Backwards, Justin?
Yes, sadly.
Oh my god.
I like when he challenges himself.
I need to get you an iPad, dog.
Yeah.
After I graduate.
I'm gonna start a
I know,
GoFundMe
I'll
for
get
you.
my iPad.
Use some of the IEEE money.
I'm gonna start a GoFundMe.
Yeah,
for you.
I think you should fund Justin since he's working to help the team. I think there should be a serious contribution. But that's just my input.
Trick Cal State all
I
day.
second that.
I third it.
Okay, on to the problem.
I'm gonna start a GoFundMe.
First equation.
Start a GoFundMe. Yeah, I'll throw in.
All right.
Yeah.
Same. I'll do it too.
All right.
Make commercials and
Justin, you about to get $5,000 for one iPad.
No.
You're about to get swag.
3.
It's a little dark. It's a little dark, Justin.
Okay, I'm gonna use a pen.
Oh, sorry.
Where's my? All right. So equation 1. Where's my eraser? Equation 1, we got 0 equals y plus x. 2, we have 0 equals y minus x. Yeah.
Yeah, that's good.
And 3, we have 1 equals y plus 2x, right? So it says make a triangle. Essentially, it's going to look like that. So it's just where the lines intersect each other. So where each equation equals each other is just what we have to find. So where 1 equals 2, 2 equals 3, 3 equals 1, and vice versa. That's where all these points are going to be to make a triangle. And from there, it's just algebra. So x plus y equals x minus y, or y minus x. So it's going to be 0, 0 pair, just because math. Let's see, that cancels. Y equals y, 0, yeah. 0, 0 pair. Then let's do equation 2. Equation 2 equals equation 3. So this is for y equals x. And that's going to go to this one right here. We just substitute that in. We have 3x equals to 1. X can equal 1 over 3. Y equals x. So the pair is 1/3, 1/3. The last one is where 1 equals 3. So y is going to equal negative x. So substitute that in. So that one, x equals 1, y equals negative 1. And that should be like A or B or something. It's A.
Hey.
Yep. And that's how you find your answer. Comments.
Yeah, man. I don't really.
2/3.
Why are you equating everything together?
Oh, because what we're trying to do is we're trying to find a triangle, right? So let's just say we have random lines. Where's the triangle? It's like in here, right? So at these vertices, this is what encloses the triangle. This point, and this point. And what you notice about the points is that that's where the lines intersect, right? They intersect and they make a point. Correct?
Yes.
Yeah. And when they intersect, that means the lines equal each other. So at, let's say 0, 0 is where, if drawn a scale, y equals x and y equals minus x. So it's going to look like this. It's going to look like that. That's where they meet each other at 0, 0. This one and this one. And then we have y equals minus 2x plus 1. So let's say y-intercept's right there. Minus 2x is going to be a little bit like, I want to say it's going to look like this, right? I don't know if you can see if there's a tiny little triangle in this thing right here, but there's 3 points where they intersect, and those 3 intersections are what encloses a triangle.
Let's see. Oh, okay. Yeah, so I just didn't see why you were equating them at first. That makes more sense.
Yeah.
Okay. GG's. Anyone have any questions?
You guys copy if anyone's still copying.
5 in, everyone's good.
Ooh, number 5.
All right. Yeah, all right. Number 5. We head to Seras.
Hello.
Oh my god.
Okay.
How's it going?
I am sharing my screen right now. Okay. Number 5. I'm ready. Okay, so the question is, it's asking for the point of inflection. Point of inflection. Question mark. So this is going back to like critical points, all that stuff, finding it on a parabola, I guess. So this graph, I guess if you were to graph this out, it's supposed to look something like this, right? And you're trying to find the point in which the slope of this, so the slope at this point changes from like positive to negative or something like that. Or when it just goes up or down. I forgot what the meaning is, but who cares? Anyway, so we have to jump into this by taking the derivative of this equation twice. So taking the derivative once, we got, so this is the first one. So we got 3x squared. Can you guys hear me?
Yep.
3x squared plus 2x, okay? Take the derivative again. I don't even remember if that's how you write it, but okay, we should end up with 6x plus 2, okay? So now we get to this point, and now we have to set this whole thing equal to 0 because we have to find that inflection point. Pretty much taking the derivative twice and setting it equal to 0 is how we get our inflection point. So we solve for x, we get something like negative 1/3, okay? And a way to check is if you plot this on like a line, I guess. I don't know how anybody else was taught, but I was taught to check by plotting this number on the line, picking a number after that number, oops, and before that number. So let's say you pick like, I don't know, 0. If you plug 0 in here and you get like, let's see, if you put, let's say if like y double prime is equal to 6 times 0 plus 2, you're going to get like a positive number. It doesn't matter what the number is, but it's positive. So we get a positive number on this side. And let's say we pick like, I don't know, negative 1, which is more negative, okay? And we check that number again into that equation that we have. We're going to get a negative number. So this proves that there's an inflection going from negative to positive at this point. Therefore, our point of inflection is negative 1/3, which is B. Any questions?
Yeah, so if you check it and it doesn't work, what happens?
If you check it and it doesn't work, then that's not your inflection point.
So then what would you do?
Well, that's
You
well,
messed up
you
the
might
math, is that the
have
problem?
other options. You might have like a, okay, so this occurs. Well, you have to do your checking just in case if you get something where it's like, let's say like you end up with like a x squared in there or something, 6x plus, 2x plus 3 or something equal to 0. And you're going to get two x values. You're going to x value, A, and then x value B. You know what I'm saying? So you have to check. You have to check between those two. But this one was yeah. This one was simple. I don't think they'll go that crazy, but they could, I guess. But that was a good question. Anything else? Okay.
Thank you, Sebas. Number
Who's 6?
Matt.
Okay.
Matthew. Moving right along. Matthew. Yeah. So these questions are a lot less challenging so far than last week, just because last week was nuts. We did electronics and control last week, so yeah, that one. This one's a little bit more, refreshed, a little more of a
We get a little break.
Yeah, a little tiny breather, just a little breather, and then we'll hit it hard next week. We're gonna do some more. I want to do some more probability next week because there's really not a lot of probability problems in here. So we're only gonna go over like 3 today, but I want to do more. That and then most likely electric machines. With the rad.
No.
I'm so glad I'm not taking that guy. Oh my god. Matthew, whenever you are ready, sir.
I think he's muted. Matt, you're muted.
Oh, he's not muted for me. No,
He's muted for me.
He's muted for
oh
me
yeah,
as well.
no, he is muted. That's right.
Yeah.
Who in the participants is a file?
I saw that. I don't know.
Yo, can you guys hear me now?
There
Yeah,
you go.
yeah. That works.
I don't know what the fuck is going on with this speaker. Anyway,
Okay, you're back.
all right, so you guys remember taking a derivative of a single variable function? When you're
Yep.
taking the derivative of a sum of terms, you just apply the derivative to each term individually. So we're gonna go ahead and do that. Partial derivative of x squared plus partial derivative of xy with respect to y, and partial derivative with respect to y of y squared. So just by looking at this, we know this first term is going to go away because it's a function of x, and we're differentiating with respect to y. So therefore, this whole thing is treated as a constant, and you know that the derivative of constant is just 0, right? So we can get rid of this. That goes away. And now we're left with 2 terms. So the partial derivative of xy with respect to y. Like I just mentioned, when you have something that's not a function of the variable that you're differentiating with respect to, that term becomes treated like a constant. So we can just pull this x out, treat it as if it were any number, right? So that x comes out in front, and then we have, let me write it over here. So we're going to have x times partial derivative with respect to y of y plus partial derivative with respect to y of y squared. Now, you guys remember the derivative of any variable with a power of 1 is just going to be 1. So we're going to be left with x right here. And then simple power rule. Partial derivative of y squared. You bring down that exponent, and your new power is going to be the previous one, subtract 1. So we're going to have 2y. That's our final answer, x plus 2y. So I'm assuming no one has questions right here, but if anyone has a question on what I did, please feel free to ask.
Pretty soft.
Pretty straightforward.
I think has everyone done? I think everyone's done. What you call it? Partial? No, not partial.
Calculus?
Yeah. Or was this calculus or was this? Yeah.
This is like
Yeah.
a right?
Technically, it's
I think
calc
this is
calc
multivariable.
3.
Yeah.
Yeah, it's calc 3, but baby calc 3. They start you off with something like this, and you're like, oh, partial derivatives aren't so bad, and then they hit you with all these weird vectors and stuff.
They hit you with like 6 variables in one problem.
Hell yeah.
Yeah. No, I think we're good. I think. Anyone else? Anyone have any questions? I'm good.
No.
Good. All right.
Already?
What's it called? I was gonna say take another one because I'm still looking at 7 right now.
All right. So which one's next?
So then, 8. You still looking at 7, 8, 9, Sebas?
Oh well, I guess I could just do 7, but I'm not too 100% sure if I can give it a great explanation.
Take some time. We have Matt at 10, and then we have Justin. 11.
Okay, sure. Then I'll just do it. Then.
Okay. You'll do it, or you'll just.
Oh yeah. Like I'll share. Here, go for it. Whatever.
Okay.
Let's see what we got here. Okay, so this is 7 here, and the question is asking. What is it asking?
This is a second order system.
Second order system.
What is it? Is it nonlinear, overdamped, critical?
What's the question? Yeah. Okay. So trying to figure out how describe the system, I guess. Describble to help describe the system. Okay.
Can't you just hit it with a Laplace or? Oh no, they need to give initial conditions for that, huh?
Yeah. So I guess the first thing starting off is to just get the characteristic equation. So does anyone remember how to get the characteristic equation?
Yep.
How do we do that?
Isn't it r squared plus 6r plus 25?
Say r squared plus, oh, okay, 6r plus 25, right?
Mm-hmm.
And then we just equal that to like 0. Okay.
Mm-hmm.
So this is our characteristic equation. Okay. And now, in the I guess in the FE reference handbook, if you have it, we have to, I guess, look at the coefficients of these certain values, I should say, and we have to set them equal to, I guess, in respective to what they are. So what I mean by that is, like this one's A right here, and this is B. Sorry. Okay. And if we take, sorry, I think my screen froze.
Also, this is on page 52, everyone, if you want to kind of see too.
Okay.
In the handbook, right?
Yeah.
Okay. Sorry, I don't have the handbook in front of me, but what's it called? So pretty much, you have to check if a squared, depending on what a squared is, and what 4 times b is, it will determine what, I guess, what the system is. So if we so let's say a is equal to 6, right, and b is equal to 25. Okay. If we square a, we're gonna get 36, and if we multiply this by 4, I think, yeah, multiply by 4, we get 100. Okay, so in our case, 4b is greater than, which is 100. Oops. Here, I'll just put it right here. 36 is greater than 100. So according to the handbook, I guess if you have it, the system is undamped, underdamped. Not sure why.
Yeah, I don't know about you guys, but I don't remember that from
I don't remember
differential
this
equations.
Yeah, I don't really remember this, but
or controls. We didn't
or
learn
controls.
it that way.
Yeah, I don't
The
remember.
hell
it.
is this?
So that's why I'm having a really hard time trying to explain this, but let's just accept it for now.
We had it for exam number 1.
What?
We had it for
what's up,
exam
Johnny?
number 1. It
Was
was
it exam
Johnny
1?
Yeah, multiple choice, remember? Where you had to check if it was time varying, continuous, discrete, underdamped, or all that shit.
Really?
Yeah.
That was one of them?
Yeah, she gave us like 3, 4 questions on this. It was 1 point each.
Oh, jeez. Well, there you go, guys. There it is. Okay. I have what number again?
The handbook. If you're having any confusion, I think the handbook will
The handbook would be clutch. Yeah.
yeah, yeah, yeah. What page?
You have
Put
it
a
open on me?
disclaimer.
What page again, Devin? 52?
Yeah, 52.
Yeah. Handbook is definitely a must in this test.
Okay. All right.
Mhm.
Moving on to number 8.
Number 8, yes.
This is another differential equation problem. Oh God, no. Why
It's
God?
in the handbook.
Okay, y double prime plus 4y prime plus 4y is equal to 0. And the question is asking you to find the general solution. Oh dear God. Okay.
If you want some other time, if you want, we can go to Justin and you can.
No. Let's
You
do
got
it.
it.
Let's do
All right,
it.
all right,
Okay.
fill in. Let's go.
So general solution. Jesus
Mhm.
Christ.
Dude, I'm low key pissed because Tabrizi said we're never gonna have to actually solve differential equations. We can just use Laplace, but they don't give us damn initial conditions. How are we supposed to do Laplace?
Okay.
She lied to us.
Lied to
Right.
us, dude.
Initial
Right.
conditions.
She
Yes.
lied to
So
us.
I guess we're going off the same equation as we did before, r squared plus, r plus, I guess b. I guess those values should have been a and b. I should have probably
AR
put
plus
the whole
B.
formula up there first. That's our characteristic equation. Okay, so and then we're gonna just plug those numbers back in there. Okay,
Mhm.
you guys better check me because I could be
Yeah.
Yeah, that's
misinformation.
Yeah, if you stray off, I'll help.
Okay. All right. And okay, I think I kind of remember what's going on here. So this is where we have to like put it in terms of it kind of looks something like I remember there's like a C1 e to the
Yes.
R. I think it's like R
I
x or
think
something,
this one would be
plus CX or something.
You have
E
to
to
find
the
Mm,
E1.
yeah, there we go.
something
If
like
it's re-
that. I think there's like a
repeated.
negative in there somewhere.
Use
Or
the
I think
negative 2x.
I think this is like B or something, or I forgot.
Something
not for
like
this
that.
one.
Not for this one.
No, that's if a squared is bigger than.
Oh, right. Okay, right. So we have to set this equal to 0 and find the. Okay, I kind of remember now. Okay, so we set this equal to 0 and find the roots. So find roots. All right, please excuse my fantasy team. They're going off right now.
You winning?
I am winning. I'm actually in first place.
I lost this week, bro.
Oh yeah, I'm getting big money right now. But I'm probably gonna get my cheeks slapped. So
I lost, bro.
4 squared minus shit. X equals negative b plus or minus square b squared minus. Okay, 4 times 4 all over 2a. If you're already a god, you already know that this is gonna equal to 2 of the same roots.
Yeah.
Plus two, no?
Yeah.
Why? Yeah. Y plus 2. Y plus 2.
Yeah. This is just gonna be plus 2, r plus 2. So we don't have to do that, but I was just doing it just in case anybody didn't know. Okay. That's gonna be you're gonna get 2 of the same roots. So since these are 2 of the same roots, and what I mean by same roots, or same poles, I should say, since this is controls, baby.
Mm-hmm.
Yeah, there we go. Same poles. You're gonna have to use this equation. Let me get it up. Hold up.
Then beautiful notes.
I'm whipping them out. Hold up.
Memory, bro.
Exam 1 cheat sheet. All right, here we go. 2 poles. Same sum repeated or something like that. Here we go. It looks something like, but we're not in the time domain, so we don't have to go that crazy. You know what? Screw it. That's just, it is what it is. So it's gonna look something like, did you just text me too?
Oh, yeah, it's the formulas you need right now.
Oh, it's the formulas right there? That's what you just shot me?
Yeah.
Okay. All right.
Yeah.
Well, just tell me, what's the formula that I plug it in? It's like C1.
Yeah, y equals parentheses C1 plus C2x parentheses e to the R1x.
Oh, it's like R1x plus C2x e minus R2x.
1. No,
What?
so it's parentheses C1 plus C2x close parentheses times e to the R1x.
Oh, well, yeah, I remember it as like not distributed, I guess. I mean, factored out, because I think you factored out the
Don't you put
ER1x, yeah.
you factored out the ER1x. Yeah. Okay.
Mhm.
Maybe R1s are positive, maybe?
Are they positive? I don't
Because if you
know.
negative,
Yeah,
like,
they're positive.
yeah, it should be
Oh, they're positive. Okay.
Yeah.
Jeez. Getting clapped here, man. Okay, I'm bleeding out. Okay, here we go. Oh yeah, you're right. You're right. So yeah, then we get, if you plug crap in. Okay, and then I guess if you simplify some more, then we should get. Oh. There we go.
Yep.
Is that an answer? Let's check.
There it is.
Yep.
Which
This is D.
that is D. Okay, cool. There we go. Woohoo! We made it. That wasn't that bad. I was crying on the inside. Okay, what's next? Am I next?
That was number 8.
I forgot which
8.
ones I said I was
That was
doing.
number 8.
Yeah. So yeah, number 9. Number 9 would be your last one.
Oh, okay. Jesus Christ. Okay. Number 9. Okay. I didn't even look at the ones I picked. Okay. Okay. The magnitude of the resultant 3 complainer vectors is most nearly. This is like some physics stuff. Okay, so let's draw this out. Whatever. All right. So we got one going like right there.
Is that now? That's awesome. Sorry, I'm just noticing the new features of the.
Oh yeah, man, it's pretty crazy now.
Crazy, bro.
I don't know if I can do that one, but I'll leave that one like that. Jesus Christ, I'm sorry. Hold up. Let me turn that off real quick. Cause people be blowing out my crap. All right, and we're back. Okay, so we got one right here. We got 5, and we got 2.12 again. Okay, so this one is A, and this one is B, and this one is C. Okay, so the magnitude of the resultant vectors. So we have to like sum all these vectors up and get the magnitude of it. Does anybody remember how to start this?
Nope.
Sum the vectors.
No. Okay, so it's kind of like you gotta treat them. I like to treat them as forces. I remember back in the day, you know, we do like sum of the forces in the x direction equals 0. Sum of the forces in the y direction equals 0. You know, et cetera, et cetera. And then from that, you get the magnitude, which is the sum of the forces in the x squared plus the sum of the forces in the y squared. So just treat it as like a physics problem. So it's just vectors. So in our case right now, so let's say we have to split every vector up into their x and y components. So we have to split vectors into x and y components. All right, is everybody with me?
Uh-huh.
All right. Okay, so let's start off with the vector A. I guess. If we're looking at this A is kind of I guess it's going to be the most interesting one, because in order to make this, I guess this vector right here, we have to come up with two vectors. So there's actually a vector going to the left, like so. That is its x vector, and we have and we have this other vector as its y vector. So we have f of x, oops, and this is f of y right here. So we're starting off, I guess we could start off with finding some of the forces in the x direction. Anybody have any questions right now? No, we're good. Okay. Okay. So they give us the oh, I forgot to put the magnitude of the vector there. What was it? It's what's the magnitude of the a vector?
5.
5.
Oh, it's 5. Oh, I stupid. I did put it there. Not even looking. Okay. So to get the magnitude of the x vector, we have this degree right here, which is 105. Okay. You could do this like one of two ways, I guess. We'll do it this way. Okay. So you take the magnitude of that vector. So let's say it's 5. Okay. And you're going to take the cosine of the angle. But since we're using I guess I forgot what the name of this angle is, the complementary angle, you're going to have to do 180 minus 105, I guess. And that should give you, let's see, what is that? Should give you 75 degrees. Okay. So if you take that will give you the resultant vector for that x direction, for A, that is. Okay. Then we have, so that's also going the opposite direction of this vector right here. So what you're gonna have to do in this case is put a negative in front of that. Okay. And you also have the magnitude of C. So let's say if I were to color code it, this is the magnitude of A. And this is, I guess, well, we have to do it in order. Magnitude of B, there is no magnitude because that is solely a y vector. There is no x vector that makes up that one. Okay. And then for B, we have 2.2 or 12, I should say. Okay. Sum all those forces up, we get, let me see. Since someone else do it too, just so I'm not tripping. I got 0.826, I guess, something like that. All right. Moving on. Now we got to get the sum of the y vectors, or some of the vectors in the y direction. So same thing for A. We're going to take that magnitude and we're going to do the sine this time, the sine of that angle, which is, what is it, 75? Okay. Does everybody know why we're using these, I guess, trigonometric properties here? Why we're using sine? Why we're using cosine?
Mm-hmm.
Cool. Okay. Cool. Sounds good. I wasn't sure. Okay. So that's pretty much as easy as that. And this time we don't have to add a negative because they're both going in the same direction. This one is going in the same direction as B, et cetera, et cetera. So B this time we can include that vector. We get 2.12. But C, there is no vector in the y direction. And we will get something like, 6.9.
Nice.
It's line 5 or something. Okay. Now we got those two. Now, if we remember our equation over here, this is going to give us our magnitude of the resultant vectors. So plug everything in. And we're going to get. Watch this not be any of the possible answers, and we just did this horribly wrong.
Wow.
No. We got to see positive.
6.99. Is that an answer?
6.99.
7, I guess.
6.999 is the answer.
Is that the answer?
Yeah.
Cool. We did it. Yay.
Yay.
Okay. Any questions on this? All right. Screw you guys. I'm going home.
Oh.
Just kidding.
All right.
Yeah,
No
well,
questions?
no questions. All right. Moving on.
Forever hold
Who's
your
next?
peace. All right. Number 10.
I think it's Matthew.
Alrighty, number 10. Can you guys hear me this time?
Yes, sir.
Yes, sir.
Okay, let's get it started.
Get started.
All right, so it's asking us to find a unit vector perpendicular to something, right? Okay, and then it gives us two vectors. A is equal to 2i plus 4j, and they give us b equals I plus j minus k. Okay. So you guys remember from like Calc 3 or even physics, when we're looking for something perpendicular, we know we're looking for a cross product, right?
Mm-hmm.
So to find the cross product of three-dimensional vectors, we have to set up this 3x3 matrix. So the top row is going to be our components, I, j, and k, representing the components of each vector, correct? And remember, cross product depends on order, highly dependent on order. A cross B is not the same as B cross A. It's going to give you the same magnitude but opposite in direction. So we have to make sure that we put A first. So you would just list the coefficients for each component. For example, the A vector is 2i plus 4j. So where we see I, we're going to place the coefficient of 2. 4 is going to go right under j. And because we have no component in the z direction, we're just going to leave that at 0. And do the same thing for vector b. So we're going to have 1, 1, and negative 1. Okay, so in order to determine this cross product, we have to find the determinant, basically. So to do that, you basically want to start off by eliminating the row and column associated with whatever component you're looking for. In other words, since we're looking for the I component of this resultant vector, you want to cancel out the row and column that contains I, and we're going to find the determinant of the resulting 2x2 matrix. So you guys remember that's just A times D minus B times C. So this is going to be 4 times negative 1 is negative 4 minus 0. That's going to give us the I component of our resultant vector. Then it's going to be minus our J component. Not really sure why. It has something to do with like the linear algebra going on. There's probably some proof that explains it, but you know, none of us have taken linear algebra, so I don't know. But let's do the same process. So now we want to find our j component of this vector. So we're going to cancel out the row and column associated with that j parameter. And again, we're going to solve that resultant 2 by 2 matrix. So it's going to be 2 times -1 minus 1 times 0. -2 minus 0. That should give us our j component. And then we're going to add the k component. So again, repeat the process, eliminate the row and column. Solve the resulting vector, determinant, I'm sorry. So it's going to be 2 minus -4, so 2 plus 4. So I'm just going to call this vector v. It's going to equal -4i plus 2j plus 6k. Does everyone agree with that so far?
Yes, sir.
Someone want to vibe check that real quick?
Looks good to me, baby.
I plugged it in the calculator for the vector, and I got -2. Okay. Maybe it was 2 minus 4.
I probably missed a negative. Let me see.
Uh-huh.
Oh, my dumbass. This is +4. My bad. Yeah, you're right. Thanks, Devin.
It's okay. We all make mistakes. Oh, wait.
So this is 2
File
minus 4
cabinet.
minus 2k. There we go. I had a negative up here for some reason. All right, so this resultant vector is the result of our cross product between vectors a and b. So this vector is perpendicular to these two, right? Everyone understand how that works, right? Everyone gets what's going on during cross product?
Can you draw it out?
Damn it, Sebas.
I think it's better if you visualize it.
Yeah, you're right. Okay, so how am I gonna do this?
I guess that you don't have to draw it exactly.
No.
Use like 2 different colors for both of the planes and
Right,
show
right.
how.
So we got some vector A that's out here somewhere, right? Let's draw vector B going this way, right? So this resultant vector, our cross product, it's going to be perpendicular to both of them. So there's going to be like a 90-degree angle. This does not look right.
I'm gonna go on the other
No, I think you should go up.
Yeah. Let me see.
Yeah. Oh,
Oh,
like
but then
straight up,
it's
straight up.
straight up.
There
Well, I was
we
trying to draw it like in space. So I was gonna have it like
yeah, I
coming
see
out,
what you mean.
I was
Yeah.
gonna have it coming out of the iPad or something,
Yeah,
you know,
yeah.
but that doesn't work. I'm not an artist.
That looks good.
Anyway, let's just assume that these are on the XY plane, right? So these two vectors are on the XY plane. Our cross product is going to be the vector that creates a 90-degree angle with both of those other vectors. Everyone get that?
See, puppy?
Everyone good?
Yep.
Yes.
Alrighty.
I totally
Now,
heard about that.
the question is asking us to find the unit vector. So this is the cross product, that's correct. But we need a vector with a length of 1, the unit vector that's perpendicular to those two. So I'm sure you guys remember how to find that. We have to divide this vector by its magnitude to get a unit vector with a magnitude of 1, correct? So let's find that. So magnitude of this vector is just going to be the square root of -4 squared plus 2 squared plus -2 squared. Should be square root of 24, which is 2 times square root of 6. Everyone good?
See, senor.
That's good.
Alrighty. Now the last step to find our unit vector is going to be dividing that vector, the cross product that we just found, divide by its magnitude. So I'm just going to write it in vector notation here. Divide by 2 times the square root of 6. So you can just distribute this 1/2 into that vector. So divide by square root of 6 times negative 2i plus j minus k. There we go. That's our answer.
That was good.
Nice.
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 Everyone good?
Nice. Yeah,
Yeah.
that was good.
I'm surprised I was able to explain that. I hate vectors.
You explained it really well, bro.
You did well.
That was good, man.
You explained it really well.
Thank you guys. Thank you. Appreciate the feedback.
I think I could teach a class now.
Am I ready to teach EMF now?
Oh God.
God. EMF's a whole.
I like EMF. EMF was fun.
Fucking hate
EMF was
EMF.
yeah. I think EMF was the easiest of all of them, especially that final.
Heck no.
Are you cheaters?
Mm,
What are you talking about? I don't know what you're talking about.
it's going to YouTube, right?
Huh?
No, so this is going to YouTube.
Oh yeah, I'm recording.
Recording, huh?
Yeah, that was a lot of math. It was ugly.
Animal math.
Yeah.
It's disgusting. All right, GG's. All right, so number 11, Justin.
Take it away, Justin.
We gotta get ready. Justin's gonna go sicko mode right now. Hold on.
Justin, you're muted.
You're muted, bro.
Oh God. Oh, he can't speak. He can't speak.
Oh no, is he having the same problem Matthew is?
Let's see how long he goes. Let's see how long he can go with that. Wait, let's wait. Let's
No,
wait and see.
In the
You
chat.
can probably hear us, right?
He's typing something in the chat. Wait,
No,
what?
no, no. He's clearly can't hear us. Let's see. Let's see how long he can go.
Okay.
All right. Okay. We gotta look at the matrix. Okay. 2x2 matrix.
Right. Yeah. It's a 2x2. In order. Okay. So number.
Wait, what was I doing again?
I don't know.
I don't know what you're doing, bro.
We didn't hear you at all.
Oh shit, that's right. Okay, so blah 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 matrix, find inverse, and I forgot I was on mute.
You didn't hear us?
No, I didn't.
Caricature board.
All right.
Charcuterie board, yes, I was looking at that. Okay, so this is the question, right? We go to the handout or the FE book, we type in matrix inverse because I don't know what that means.
Looked for that. I couldn't find it anywhere. Damn it.
And it's
It's in.
right here, this formula. I don't know what this means, or this isn't important. This is a pain in the ass. But what's important is down here, the determinant of A. So what makes a number invalid is gonna be like, if this is 0, right? If this is 0, then this goes to infinity. And then it can't happen. Okay, so back to this one. Just make this 0. So 2 times k plus 4 times 3 equals 0, and then you know math minus 6. You guys want me to write that down, or you think?
Write it down, please.
Oh, okay. So the goal is for the determinant of A to equal 0. So A is going to equal 2, 4 minus 3 k, right? So determinant of A is going to equal
Hey, Justin, I can't see your screen if you're presenting for some reason.
oh,
I don't know if it's just me, but I can't. Well, I can't see what you're writing. It's like you're on a small view or something. I think that's better. Yeah, that's better.
All right, so that's the goal. Determinant of A equals 0. It's your A matrix. Determinant of A is 2 times k minus -3 times 4. That's going to be 2k plus 6 equals to 0. K equals, I did this wrong, 12.
Mm-hmm.
That's right. Math is hard. K equals to minus 6. Yeah. This is mainly just finding stuff in the handbook.
I'm good.
Thanks, Justin.
I'm good. That was great. Thank you, Justin. You want to move on to
Gracias.
number 12? This is where it starts being fun.
Oh, that one's super easy.
Yeah.
Probability, baby.
No, that's not probability.
No, this next one is no. This one next one.
12? No, that's not probability, bro. That's
no,
like
no.
that's like
My
some.
bad. 13 was 13.
I was like, what?
Okay, for this one, you just cross out the ends until you get to the middle, and that's your answer.
But there's 8, Justin.
So
Yeah,
what-
Justin.
Yeah, explain that, Justin.
11 and 12.
So now what?
Now what?
You have to find out what's in the middle of 11 and 12. So you just go, you meet it halfway.
You take the
11
derivative.
and a half.
You got to integrate.
Oh yeah, you're right.
Well, in reality, you just have to add them up and divide by 2.
Oh, yeah. And you halfway.
I hope I get this on the FE.
That is like that is going to be the easiest problem ever on the FE, bro.
Or
No,
the
they try to
boat.
trick you. Like, this side is all 11. So if you miss crossing out one and you're like, oh, it's between 11 and 11, then
Maybe.
Yeah.
That's the middle two up and divide by 2.
oh, for these two, the middle, yeah.
Got it. Thank you, sir.
Because you're left with 2 in the middle.
That makes sense.
Yeah, what's number 13? Oh, this one you have to use the handbook again. So like the mean is 8. It's a normal distribution, so you know it's a bell curve. It has to do with like standard deviations and whatnot. So our standard deviation is 2.5, right? So if you do algebra, oh yeah, and we're trying to find a more than 15.5. So if you do algebra, how many 2.5 standard deviations away from 8 is 15.5?
What?
2.5 is the standard deviation increment, right?
Mm-hmm.
8 is your center. and we're trying to find 15.5. So how many standard deviations is that? How many increments?
That's a good question.
Anyone?
3?
3.
Yes, there you go. Because 15 minus
Let's
8
go.
is 3 divided by 2, or 15 minus 8 is 7.5 divided by 2.5 is 3. All right, so we know it's 3 and it has to be greater than 3. So then we go to handy dandy handbook.
What page is this on?
I have no idea. I'm gonna look it up.
What number are we on? Sorry, I was.
13.
13.
Maybe you look under standard deviation.
Oh, that's like sigma, isn't it?
I think.
It's sigma, and then I forgot.
Okay,
There it
yeah,
is.
something like that.
Oh, that's not it.
I'll go with what Devin said. Standard deviation.
Oh, you
Very
just
sad.
had it. You
Yeah.
literally just had it. Page 63. Go up.
Page
Page.
63.
Yeah.
Oh, the first one. Okay. Here you go. It's these things, right? So we're looking for like something on the right and the shade is greater than that because that's what the question's asking. More than 15.5. And that's more than whatever x value. So this is what we want. And then what's our x value? It's 3, right? So you go all the way down and then you find 3. It's going to be 0.0013. And, you know, it's A.
Damn. I
Oh.
didn't even know how to do that. That's crazy.
Kind of reminded me of econ when you had to go to those charts and stuff.
And
Yeah,
tables.
I didn't even know that. Wow, you taught me something new today.
Yes. Or you can do the formula, but nobody has time for that.
No, hell no.
All right. Oh, this one's an interesting one. 14. You have a fair coin that you toss 10 times. The probability of getting exactly 4 heads in 10 is most nearly, okay, let's do this one.
Oh, I learned this. I'm taking prob right now, and I actually know how to do it.
Oh.
Would
Maybe
you like to do this, Matthew?
take it away, Matthew.
Yes.
Let me see if I really do know this, because I have an exam next week, so I probably
See if
should
you
make
know
sure
your
I know how to do it.
Yeah, you see if you know, buddy. Mister, I'm taking probability right now.
Oh, you
Gonna
used
have
to?
an exam.
Watch me get it wrong now.
I believe in you.
You guys are throwing bad vibes my way. I'm gonna get it wrong.
Ah, bro.
What happened to the file cabinet?
Hey, who is that?
Oh.
I have no idea.
That's scary.
Is it because we're throwing 50 hertz at you, Matthew? You need it at 60?
What?
Stop. Just stop, bro.
All right. So it's flip a coin 10 times, right?
Yep.
Yep.
10 times. And the probability of getting heads 4 times,
Yes.
right?
Yeah.
Those 10 tosses. Yeah.
All right. So this is a little something called Bernoulli trials or Bernolini or whatever, right?
Sounds like a pasta.
So,
I love that pasta.
so when you're performing a Bernolini trial, that's basically when a simple experiment is repeated several times. So we're trying to find the probability that this outcome is going to be heads 4 of those 10 times, right? So our n is going to be equal to 4. It's the total, sorry, that's k, my bad. K is the number of times you want the outcome to happen.
Can
So
you draw the?
the
Can you write the formula?
Yeah, I'm going to do that right now. This is just the condensed version. So k is going to be 4. That's the number of times we want this outcome to occur. And 10 is the total number of trials, or n, right? Multiplied by the probability of getting of a success or the outcome that you want, which is heads. So of course that's a 50% chance. And that's going to be to the power of k, so to the power of 4. And then this is going to be multiplied by q, which is 1 minus p. So in this case, it's exactly the same, 0.5, to the power of n minus k. So this is going to be 6. All right, so the actual formula for this is going to be n factorial over k factorial times n minus k factorial times what I just said, 0.5 to the power of 4 times 0.5 power of 6. So then you just plug in your values for n and for k. So 10 factorial divided by 4 factorial times 10 factorial. Shit, my bad. 6 factorial. N minus k. Then you just plug and chug. Alrighty. Anyone solve this yet, or do I have to plug it in?
No, just it's 0.2051.
Dame.
0.2051?
Yeah.
Alrighty, thank you for that.
Yeah, no problem. I wasn't
Isn't
gonna.
there another way you can do it too?
There is.
That's what Johnny was asking me, and I completely forgot.
Okay, wait. Can I draw it on the screen right here? Hold on, because I
Yeah,
remember.
go for it.
Okay, just leave it there. So
Yeah.
I remember like you can go
Oh.
like this, right? And then it can go two ways. This is the second time. Or something, and then the third time, it can go like. But from these outcomes,
Yeah.
it could be like heads or tails and stuff like that, right?
Right.
Mm-hmm.
But I
Heads
mean,
or
it's up to you if you want to write that whole.
That's a
Yeah,
lot
for
with
10
out,
times. Yeah, 10 times. Obviously, that wouldn't be optimal. This is like 1, 2, 3. Yeah, I remember doing it like that. But that's interesting. Yeah, I never remembered how to do it your way that you're doing. I didn't even bother answering that question, TBH. I just fucked up really hard. Anyways.
And it's on the FE, bro. So, GG's. All right, so.
Alrighty.
Thank
Hopefully,
you.
you guys understand Bernolini trials now. Bernolini or whatever. Bernoulli.
Bernoulli?
Bernoulli.
Granola.
Shit, I'm hungry now, man.
All right, so that's pretty much all of the questions that we had for today. If you guys want, we can add
Among Us.
a couple more analog if you guys really, really want to. But
Nah.
that's pretty much it for today for everyone. Thank you again for coming to what is this, week 3 or week 2? Week 2 of
Session 4 today.
session 4. Yeah, let's
Session 4.
do session 4 of the
It is?
EIT. Yeah, study sessions.
Nice.
So far, so good, everyone. I really do hope this is helping, because that's literally what the whole purpose of this is. I really hope it's helping.
So are we getting our results back tomorrow?
It's a good question. I'm not too sure. Johnny?
Why tomorrow?
That's what you said last week. By Friday?
No. I said they were gonna give us a score, not like exactly 1 week after. You get me? Yeah. I mean, they're reviewing like 20 exams right now with 100 questions.
Yeah, 100 questions each. I don't think it's going to be for a little bit.
So give it a week or something.
Mm.
Yeah. So if y'all want to stick around, feel free. Excuse me. Feel free to. If you have any more questions about any of the questions today, feel free.
But you guys want to see something? And try to see if you guys can help me.
Go for it.
Just, just look at it. Just look at
Floor
it.
is yours.
I'm actually gonna dip out right now, guys. I gotta help Sean out with this fat lab report.
Oh yeah.
Alright.
Good.
All right. Thank you, Matthew.
Yeah, no problem. You guys have a good night.
Have a
As
good
well,
night.
dude. Thanks again. Good night.
With me.
Does anyone understand this?
Oh hell no.
Looks like a whole lot of electronics, but what's
Yeah.
the question?
What class is this for?
It's analog integrated circuit.
Hell
Damn, you fucked up, Kim.
I should have just taken a Spanish class or something.
I'm taking a Spanish
Yeah.
class right now, bro. I
Take
don't know why.
systems. Systems is super chill.
What is?
You know what? I think I might take that next semester, Justin. You've
What is
inspired
it?
me.
Systems?
What number is it, Justin? What class is it?
4130.
4130. I'm gonna write that down.
Don't tell
What's the
Sean.
requirement?
Controls.
Oh, okay, I'm gonna do that for
are
sure,
you taking?
bro. Is
I
it
said
offered
don't
next
tell-
semester?
I think so.
Prereq, it's controls. I don't-
4130, huh?
Yeah.
See you later, Andrew. It's
See you,
nice having you here.
4130? Oh shit.
Yes. Well, there you go. You can find it right there.
I mean,
Systems engineering, huh?
Yep.
It's easy? Who's the professor?
Harris. Joel Harris. It's like the only
Is-
white guy.
Is he cool? Like,
Super cool. He's chill. He's like, okay, if you're not gonna do homework or if you're gonna miss an exam, just tell me. I'll work with you. And like a guy's like, oh, I can't do this. So he's like, oh, no, yeah, he's really nice. Really nice.
don't tell Sean that, because he was picking between this class or systems, and then I was like, if you take analog, I'll take it with you, and we're dying, and you're telling me systems is chill.
Yeah, we're just like talking
Fucked
about.
up.
Yeah, we just talk about it's more like managerial stuff.
What?
And how to
I'm gonna
oversee
take
a
it next
project.
semester.